Here we are going to discuss about net force. So what is mean by net force? For that we have to take a small observation here. For that, so here I am taking one example. So first select the table or floor. On that we have to place one duster. Right? Here I am able to take one action. Right? So simply to know about net force, first you have to take the object on that one side you have to apply the force. Here I am able to apply the force from my right side. My right side. Here I am able to apply one force on the duster. Then the duster is start moving or not? Because still I am able to apply the force on it. Then now I am not applying the force from my right hand. Then I am able to start applying a force from my left hand. So means left side of the duster. Then the duster is moving to the right side. Right? So one more action. See, the duster is exactly middle of the table. Then I am applying the force in both sides. Right? From left side and right side. In which side the duster is moving? Can you clearly observe once? In which side the duster is moving? From right side or left side? For that, answer is in no side. It is at same because I apply the force on two sides. Means in two opposite sides I am applying the force. Then from this we are able to understand. Right? So already we have discussion when a object or a material present on particular floor, right? It can able to notice two forces. In upward normal force, in downward we have the existence of gravitational force. Then whatever the force is applied on the duster by my hand, that we call as muscular force or force. Then in moving time, already we discussed, when a material or object is in moving on the particular surface, it can able to notice the frictional force. Means in moving time we can able to notice four types of forces. In downward gravitational, upward normal, applied force and frictional force. Applied force is the moving direction of object and frictional force is exactly opposite of that. Because if you stop applying the force, then the duster is able to stop because no force is acting. In opposite, we are able to get the friction from the table which is acting on the bottom of the duster, right? Then from this we can able to understand what is net force. Simply, in moving time, four forces are acting or not. The sum of all forces which is present on object. Here object is duster. Then that all forces which is present on the duster or object, that we call as net force. Right? Here same thing we written. Algebraical sum of forces acting or present on object is called the net force. Right? So this is the definition about what is net force. Right? Simply you have to take same experiment, same observation while you are able to watch this video. Right? You will get a good clarity. When you apply the force on the duster, you will get a movement to the duster. Means it is possible to move. When you not apply the force, it is at same place. From that we can able to understand. Right? Have you got the clarity? Then here to know about that net force and how it is calculated, we have to take one more example. Are you ready? For that, same this table, you have to push from one end. Then it can able to move. Then push it from left side, it will move. Right? If you push in both the sides with the same amount of force, it never moves. Right? It is not only for this duster table, it is also for when a vehicle is struck in the mud or on the road. Right? So all members to push the vehicle, they are able to apply the force from one side, either front side of the vehicle or back side of the vehicle. But no person is able to push the vehicle in opposite sides. Because if the members are able to push in opposite side, some members from front, some members from back, the vehicle is exactly at same place. But if you are able to push in one side, then ultimately it will come out from that particular struck out place. Have you got the clarity? So this is the explanation about net force. Have you got the clarity? Now we are going to discuss about how to calculation the net force. For that, here this box you consider as the material or object, these arrows, whatever I drawn here, that you consider as applied force, or the force is applying or acting on that. Then here you observe that two arrows are there. Two are acting from only one side. From which side? For this object, only I consider as left side, because both of you and me is in left side of that, right? So simply you have to consider that, right? Then at this time you have to do one thing, right? Here two forces are acting from left to right. For that, two forces we have to add. So we have to add in the forces, because two are acting from same side, and that action is moving to another side. So two are there from left side and moving to what? Right side. For that, these two forces we have to add. Means here the forces are adding up. Same thing here we can able to see one more thing. The box is as it is, but here arrows are different. One is from front side, another is from another opposite side, right? Means both are showing same direction. See, this is also having from left to right direction. This is also having left to right direction. But in the previous condition, the arrow is exactly same side. But here we written one is at left side, another one is at right side. But the direction of arrows is in same side. Means one fellow is pushing, another fellow is pulling that. Right? Here two fellows are only pushing. That is the indication. Then here we have to take again add. Means we have to addition the forces in both the types. If you have force arrow marks like this and like this, the particular mathematical action is only addition or adding of forces. So this is the first case, right? You have to take one more example. Here one object is there. Then here you have to observe two forces are acting. How like the forces? One is left to right, right? Another one is from right to left. Two are opposite side, right? When two forces are acting in opposite side, right? Then you have to take this one as subtraction, right? Sometimes it is not only like this, just you have to raise this and able to take like this. One force is in left to right side, another force is right to left side, right? This one indicates again subtraction, because two forces in opposite direction, means one fellow is pushing, another fellow is pushing in opposite side. So for that we have to take calculation as subtraction, right? So these method we have to follow while you are calculating the net force. Then we have to take few example problems here, okay? Take the problem is like this. So this is the object and 5 newtons. Already you are familiar, newtons is the measuring unit of force, right? Force having the units as newtons. Here 5 newtons force is acting from left to right. Again 3 newtons force is acting on the object from left to right. Both are in same direction. So here you have to write two forces acting in same direction, right? For that, net force is first force plus second force. You have to write F1 force and F2 force. This is F1 first one, this is second one, you have to consider. Then 5 plus 3 you have to write. Then 8. Then total force acting on the object, total net force acting on the object is 8 newtons. So like that you have to calculate. Then here one more problem. Here one force is applying from top to bottom, and here one force is acting only in downwards direction. Again here both forces are in same direction, right? For that you have to add same forces, F1, F2. Then net force is equals to F1 plus F2. Then here 10, here 1. 10 plus 1 is equals to 11. Means the total net force is 11 newtons. Like that you have to solve. Okay for you? Then here we have to take one more example, that is an object is present like this and two forces are acting. One is 7 newtons force, another 5 newtons force. Then here the direction of forces is quite opposite. Further, in this condition we have to take the right subtraction, because two forces in opposite direction are not. Further, we have to take same one diagram. Two forces are acting in opposite direction. Opposite direction. Then, for that, what is the value of net force? Here, net force value is already taken subtraction, because two are opposite side. Then you have to write F1 minus F2, because two are in opposite direction. F1 is from left to right and 5 newtons force is right. Then you have to take 7 newtons minus 5 newtons. No need to write the newtons, just 7 minus 5. Then the output is 2 newtons force. 2 newtons force from which direction? So 2 newtons force extra which acting from left to right. Then ultimately object can move from left to right in the given problem. That you have to write. Okay? Have you got a clarity? Then here one more problem. See, here 3 newtons force is there, here 1 newton force is there, and here 4 newtons force is there. Then in this problem is, here two forces are acting from left to right, and here 4 newtons force is acting opposite side. Then in this condition, which forces are acting in same direction, that we have to take care of. Here 3 newtons force and 1 newtons force is acting from left to right. For that, these you have to take addition. And this 4 newtons force is opposite direction to these two forces. For that, we have to subtract. So same thing, this one you consider as F1, this is F2, and this is F3. It is not filling, right? Here F1, F2, F3 indicates forces, right? Then here you have to write F1 and F2 forces are in same direction, that you have to write, and F3 force is opposite direction, that you have to write, right? Then what is the value of net force? The net force value is F1 plus F2. These two forces you have to add, and this one you have to subtract. Minus F3. Here F1 value is how much? 3. F2 is how much? 1. And F3 how much? 4. Minus 3 plus 1, 4, minus 4. It is equal to 0. Means net force value is 0. How much force is applied from left to right? Same thing is applied from right to left. For that, total value of net force is 0. That indicates object never moves at any direction. It is at the same place. Like that we have to write and able to solve the problem. Okay children? Have you got the clarity? Here one more type of problem, right? So here object is like this, and here 9 newtons force is applying from top to bottom, and here 2 newtons force and 6 newtons force is acting from bottom to top. At this time, these two forces are in same direction because they are acting from bottom to top. Means these two are pushing, right? And this one is able to apply the force in downwards direction. Means it is able to push it down. These two are push it up, right? Then this one we should consider as F1. This is F2 and this is F3, right? Here F1 is acting downwards, F2 and F3 is acting in upward direction. For that, net force is, these two are opposite side or not? These two are same side or not? That you have to write. Here net force is F1 minus, here F2 and F3 is in same direction, that you have to add. So F2 plus F3, right? I am not writing total content. You have to write F2 and F3 is in same direction, F1 is opposite direction. That statement you have to write while you are solving the problem. Then take the values. Here F1 value is how much? 9, right? Then F2 value is how much? 2. Then here F3 value is how much? 6. Then we have to solve that. 6 plus 2, 8. 9 minus 8 is 1. So the net force is 1 Newton. Then the object can move in downwards direction, means it is able to drop on the floor, because 1 Newton force is more in the entire opposite action of force. That you have to understand. Have you got a clarity here? Okay? Now we are going to discuss about FBD diagram. What is meant by FBD diagram? Simply we call the free body diagram. Free body diagram. That indicates, right? If you take for any material on a particular surface or on the floor, what forces are present, that you have to get the information from FBD diagram. It is two types of conditions are there. First type is simply state of rest. Another one is state of motion. Right? So again this state of motion is subclassified into two types. One is on a plane surface, and last another one is inclined surface. So we have totally three types, right? Here state of rest, here state of motion. Again state of motion subclassified into two types. So in all these conditions we can able to see what forces are present on the object if it is on the floor or any particular surface, right? In that, first we have to take the consideration or explanation about state of rest. An object is in state of rest. For that, here you have to see one condition. See, here I am taking one duster. The duster I am placing on a particular level of surface. Then, if I remove this, right, this duster is directly falls, right? So I am placing like this, again see, right? So this one I am simply removing. Then what happened? Ultimately it can able to drop, right? Due to acting of two forces. One is, so in the upward direction we have normal force. Then ultimately that force is from what are the surface and which acting on the surface of duster. Then in the same time it is dropping without of this particular what are the wooden blanket taken, right? So that indicates gravitational force is present, right? So two are in opposite direction, right? And having same amount. For that only it is in state of rest. So for that, when object is in state of rest, first we have to take any one particular floor, and over that we have to select the object. Then in downwards gravitational force, right? And in upward we have to write as normal force, right? Only two forces are present. One is gravitational, another one is normal. So gravitational force towards the downward direction and normal force is in towards the upward direction. That is the FBD diagram for an object is at the state of rest. State of rest or not? See, it is not moving, right? So this particular condition is drawn at here, right? Now we have second type of condition, that is a state of motion on a level surface, right? Means an object which is moving on a level surface. Here this particular wooden plank I consider as the surface and this duster is object. Then this one is moving from my right side direction to left side, right? So right to left means I am applying the force in the direction. Then what forces are present? For that we have to draw the FBD diagram. For that, this is level surface, right? And on that we selected the object. So object is present. Then same like previous, it is gravitational force. gravitational force in downwards direction. In upward direction, normal force. Normal force. Then it is moving from right to left. So that is moving in this side or not? That indicates force by me, whatever applied. Right? Moving or not? Same direction. Then in opposite direction, we have the existence of friction. Right? If I stop applying of force, ultimately what happens? Okay. We are going to take a small discussion when object is moving on a level surface. So this, whatever the wooden plank is there, that you consider as the surface, and this duster you consider as object. Then when I push this duster, so it is slowly moving to my left side, right? Then what forces are acting on this particular object? Thus we have to take the location. So this is surface, right? Then on that we place the one object, right? Then that is moving, same like previous. Then in downwards, we can able to see gravitational force. This is the first one. Gravitational force. In upward, we can able to see normal force. It is common. Whether it is state of rest or state of motion, these two are common. Then that is moving to the right side or not? That indicates it is applied force or force. Then when we stop the applied force, ultimately it is able to take into rest or not? Means it is going to stop or not? Then that indicates the opposite side we can able to get the friction. So always moving object opposite side we can able to see the friction. So how many forces are acting? 4 forces are acting. In which condition? When object is in motion. Same thing written, state of motion on a level surface. Who is on motion? Object is on motion, right? So that you have to take a look for FBD diagram. It's clear? Now we have to take a discussion about if object is moving or a state of motion on a inclined surface. Inclined surface means slope. For that, so this plank I am able to convert like a slope. For that, we have to lift like this. So this is the inclined plane, means it is a height place and it is in down place, right? So it is in somewhat a slope or not. Then this object is able to move like this. See. Moving on. So simply, for that what forces are acting, that we have to draw on the board to know FBD diagram, means free body diagram. So as it is in downwards, we have to write as gravitational force, right? Gravitational force. Then in upward direction we can able to see normal force. These two are common. Then that is moving to downward point. For that, this is the force, and in exactly back side it can able to exist with friction. So these are the 4 forces which is present or acting on an object which is on a inclined surface, right? So these are the informations are easily to get by drawing of FBD diagram, means free body diagram. Have you got a clarity? Now we are going to discuss about a concept as pressure, right? To discuss about this, first we have to take the information, or we have to take initially definition. Simply, the amount of force which perpendicularly acting on a unit surface, that we call pressure. Means if you take any particular surface area, so in that we have to take a perpendicular force. For example, this one, this hand you consider as the surface, and this finger you consider as the applied force direction. Then these two are perpendicular or not? So how much force is acting on a unit surface area in perpendicular direction, that we call as pressure. For that we have to write pressure is equal force by area. right? So here we can able to get one more thing. Simply pressure we indicates with the P, that we call as force F, and area we can able to simply notate it or denoted with A. P indicates pressure, F indicates force, A indicates area. Then we already know force we can able to measure in newtons. This is MKS unit or SI unit. And area we can able to measure meter square, because meter is the unit in MKS unit for distance. Here area means either the square means S into S, or if a rectangle means L into B, whatever it may be. Then ultimately pressure units is equal to Newton per meter square, we call as Pascal. What we call Pascal. Newton per meter square, that we call Pascal. Means 1 Newton per 1 meter square, that indicates 1 Pascal. So Pascal is the unit for pressure, right? Then we have to take a activity to know about the pressure, right? Shall we take one activity? Okay, we are going to take activity about pressure. For that, first we have to select a surface. On that we have to take one object. Here I taken surface as table and object as duster. Then we are discussing about pressure or not. Then how to know about pressure? Simply, any force which acting on perpendicular direction on a unit surface area, that we call as pressure according to the definition. Here, so this particular duster, whatever the surface is having, that you consider as surface area, right? Then you have to place the hand like this and you have to press. So pressing means we are applying the force or not. So I applied only less amount of force, right? Or certain amount of force. Then the thickness of duster is decreased because I applied the force or not. If not, take this chalk and simply you have to place and able to push it, right? Then it can able to minimize its thickness, right? Then same thing you have to place in perpendicular direction. So when I place it like this, the surface area, the contact area is more. But when I place it like this, right, the contact area is less. So with a little amount of force, right, see, with a little amount of force it can able to show more pressure, right? So always pressure is more when you have a narrow or a short surface area, and pressure is less when you have wide surface area. For that we have to take one discussion. If you take chalks, we have sharp end and we have blunt end. Blunt means it is having more thickness. Sharp means already you are familiar, it is having very slight edge, right? To cut the vegetables, we can able to take sharp end to cut easily, because if you apply less amount of force, the pressure is increased highly. For that, it can able to break the material into two parts. For that, cutting of vegetables are very easy task with sharp end, but it's not possible with wide end or blunt end. So that is the clear information or clear explanation about how pressure is changed based on surface area, right? Same thing here we discussed, right? So what's the discussion? Simply force by area. Force is same. If area we have the change, ultimately it increase the pressure. So same thing we discussed, right? Then one more thing, if you take needles, sieving needles, right? It is having very sharp edge. For that, it is that particular needle easily to penetrate, means easily passing through the cloth, right? If you take blunt one, means it is not having any sharpness. Ultimately, it never penetrate into the cloth. For that, we are not able to get a proper stitching, right? So that is also one example, right? So otherwise, I have to give one task to you. Take a pen, right? Then remove the cap. On removing of cap, we will get two ends. One is pin side, another one is blunt side. Means front part of the pen, back part of the pen. With the back part of the pen, you have to apply the force on the left hand palm, right? You will get a little amount of pain. Then we have to place reversing, means with sharp nib. Just we have to push on your palm of left hand. Then you will get a more pain, because with sharp nib, right, it can able to show more amount of pressure. Further, you are able to notice the pain or not. So that is the example how pressure is changed based on surface area. If surface area is more, amount of force is same, pressure is less. If surface area is very less, amount of force is same, the pressure is more. That you have to keep it in mind. Moreover, the units of pressure is Pascal in MKS system or SI system. Have you got a clarity?